So today, I'm going to talk about future-proofing your Go API, specifically a HTTP API. It's actually my first Go talk, so bear with me. The talk may seem as though like, oh, I know how to future-proof. You're going to leave here and you're going to install something and it's going to be taken care of. When in actuality, this talk is the consequence of me definitely not future-proofing my APIs more than once. So just give a quick overview of what I'm talking about. First, I'll just introduce myself, and then I'm going to define what I mean by future-proofing for the sake of this presentation. And then I'm going to present two open source projects I've worked on within testing and versioning that are actually not based on anything really in Go, but I actually think work really well in Go. So first, hello. I've been working with Go for the last 5 years or so. Most recently, I was leading API development at a startup called Beam, where we were building out a bunch of different video-based news applications. Before that, I had a startup called Battery.io, where we were building a lot of sort of developer tooling and collaboration stuff, specifically around Docker. So all in all, I've ended up spending a lot of time thinking about the sort of developer experience around building APIs and services, and have encountered every sort of problem you can imagine on the way. And just to get a sense of the room, how many people here have written an API or any kind of web service in Go? All right, sweet. So I can't make up anything. Good. Whole separate presentation now. Cool. So when I talk about future-proof, I definitely do not mean a magical solution or some sort of set it and forget it. There's no go install solution kind of thing. What I'm talking about is how can I make sure that the programming and work I'm doing right now doesn't bite me in the ass in the future, right? Doesn't create more work for me. Whether that's a bunch of superfluous code that makes what I'm doing now work, or maintain the interface that I'm setting forth. And it's not necessarily a purely code solution either. It's sort of like a principle, a thought process, something that your team can take on. And my hope is that through this talk I can share some of my experiences and strategies, and we can have more conversations about that later. So just taking the definition of an API and thinking that through future-proofing, sort of three parts, right? There's the application, and this is the thing that, for the sake of this talk, we can't change, right? This is how the business evolves, the features that are added. This is a constantly sort of evolving element. The second part is what we can actually do, which is program, right? This is how we implement those features, those changes, how we are productive and keep what we're doing stable. And then lastly is the interface, and this is like the grand contract that we establish with our users, whether that's a public API or sort of privately consumed API. I studied math in college, so I think like everything in my life is a minimization or maximization problem, for better or for worse. My girlfriend definitely thinks it's for worse, but in this case, I think we have sort of three elements in our minimization problem, right? We have an application which is constantly evolving. We have our programming, which is sort of like the function with input values that we can adjust. And then lastly is our true constraint, which is our interface, right? Once we put it out there, people are consuming it, we can't change it at all. So for the rest of the talk, this is kind of like the crux of it. And I think to successfully future-proof means that you've minimized your programming effort and kept your interface stable. So to this point, it's completely unclear why this is actually a Go talk, which I totally get. But I think the reason why, besides the fact that I write in Go, which obviously helps, it's that Go is extremely productive for writing APIs like this. With the standard library, HTTP and all of its subpackages, the testing framework makes it really easy sort of out of the box to write an API. Secondly, when you think about an API, you think about resources and relationships between resources. I think that makes a lot of sense in sort of the type and interface model. And then lastly, which I think is maybe least documented, but most impactful, is the community and its expectations around API frameworks. So when you think about something like Node, where there's 15 different ways to write an API server and none of them integrate, goes to the exact opposite, right? Everything comes back down to a handler function that takes an actual HTTP response writer, an actual HTTP request. Everything exposes serve HTTP in one way or another. So I think being able to take advantage of the core library and then those sort of expectations that the community have makes it really easy to write tools to solve these kinds of problems. Cool. So for the first part, I'm going to talk about testing. And this is like the first line of defense and like proving that what you're writing is future-proof. And it's actually not even really future yet. It's like the now. It's like now proofing, and which is maybe less exciting in the future. Definitely works right now. Cool. And sort of the goal is to be able to prove that the code you wrote, so your programming effort, that second part, is true and it works, right? And you write tests to prove that that's the case. So I'm sure we've all seen this before, right? This is the most basic JSON API. Imagine it's a blog that has, a title and a body. And then we have the tests for it, right? And here we're leveraging the HTTP test package and some of the JSON packages to decode. And the responsibility here is entirely on me, the developer, right? I've decided that I'm the one who dictates whether or not this is a successful test, right? That the interface is stable and that my programming works, right? So that's me evaluating the status code, the content type, parsing the body, determining the title, wondering if the talk is going well, right? And which, who knows? But what I really care about is something much simpler than what's on the right, and it's just this, right? This is the only thing I care about. This is the interface. So kind of thinking in a non-Go-ish way, I'm not thinking about types or checking values or anything. I just want this string to be true. So the question is, with Go, is there an easy way to make this evaluation? And there happens to be. Right? In the HTTP util package, there's a bunch of methods surrounding how to display a request or response to sort of inspect what's happening in that request-response lifecycle. And Go is telling you what it sees in that request. So rather than me saying, oh, well, there's a status code, there's a content type, the body has to look like this, Go will just tell me. And thinking about future-proofing, this is the thing we care about. Right? We don't care about my ability to write proper tests and make sure that they update correctly over time and all that. We just care that this is always true unless we decide to change it. So at the last company I was at, we were thinking a lot about this problem, right? We're a small engineering team. There's lots of new feature work that we're doing. If things break, we don't want to spend all of our time auditing why the test broke, and we want to be thinking about the new things that we're building. And the only thing we care about is that this doesn't change. So the first project I'm going to talk about is called Abide, and it's to ensure that our code abides by the interface. And this is sort of the first project that takes inspiration from something that's totally not Go. I don't know if anyone here's worked with React before, but the Jest library for snapshot testing, right? The objective there is not for you to write out complex tests to understand what your React tree looks like. It's just to say, this didn't change, right? I did a bunch of other things. I made some performance improvements, but that thing didn't change. Right? So that exposes two things. First is an assert method, which integrates directly into the testing framework, into the HTTP framework. And then the second part, which is taking advantage of interfaces, and the idea that any resource in our API is something that we can assert against. So I'm going to kind of show what that looks like compared to the original API that I had first shown. So first, this is the snapshot. So if you worked with React, this is basically what it looks like. And this is the HTTP dump response method and what it prints out. So now if we go and look at our API implementation, right? We made a couple of changes. I've decided I think the talk's going fine so far, so we're going to make that critical API update. I don't know if it is, but and the main difference now is we're going to look at the tests. The tests are much simpler now. It's no longer my responsibility to check the status code, the content type, all those kinds of things, right? I've already decided what those things are in my API handler. So instead, I'm just passing it to this assert method and asking, hey, did anything change? It's sort of a catch-all for this particular test. Well, obviously something changed. So if we look at our tests, which we've integrated into, and we can see something is wrong, right? So clearly, somewhere in my API improvements, there's been an error. And what's cool about this is two things. One, the test has sort of acted as a catch-all. So no matter what else I'm checking in the test, right, if I'm checking to see if something about the persistence layer changed because of an operation that took place, or if I'm improving performance, I can always verify that the interface that I've decided that we're going to have, that constraint in the minimization problem, is true, right? That it holds, and it's also actionable, right? So if I decide that this is an appropriate change, I can save that. And the cool sort of bonus byproduct is that that's part of my version control now. And I think, thinking back with exactly what happened here, the most critical parts is that we're integrating with a lot of things that Go already has, right? So even though we've kind of taken a detour into a totally different, Node.js land, React land, we're still holding true to sort of critical parts of Go, right? Which is using existing frameworks, integrating into the testing workflow, right? If we have some kind of new process that's going to require people to onboard into, that doesn't make sense. But most importantly, I think what we learned was future proofing is actually much more about history than it is about thinking about the future. It's thinking about how do I document, understand how my API evolves over time, and have better observability into what the API is now and maybe what it previously was. And if I continue that trend, then as changes do occur in my API, I'm better prepared to handle those. So speaking of changes, obviously, your interface isn't going to stay the same forever, right? So you have to start thinking about how you version your API. And I think this is like the future part. We've talked about the now and the past, but thinking about the future. And the real world scenario here is, you have a mobile app and the API deployed at a certain version and people are still using the app, and now we have to hope that they either upgrade very quickly or API can still support them. This is kind of like a first pass of how someone might do that right now, right? So you can have handlers assigned to specific endpoints that are for specific versions. That kind of allows us to isolate the specific version logic, right? But that's still a lot of code, a lot of copy and paste. The second option is that we sort of have a way to switch or make different operations based on the version within the same handler. And that's fine, but obviously as the number of versions increases, this becomes really problematic, right? Thinking back to our principle, we're going to end up spending a lot more time programming to make sure this doesn't break than we are going to be adding new features and releasing new versions. So I ran into this problem a few months ago, and I thought, okay, well, how am I going to solve it? So I obviously Google it. First critical step of anything. And Stripe actually had written a lot about this problem, right? So I don't know if anyone here has used the Stripe API before, but they release versions like every day, right? There's not this big dramatic, V2 whatever release. It's just whatever day it is and the thing that changed. So they explain how they do that, right? So they definitely don't do either of these things. What they do is something kind of like a Ruby migration, right, or Rails migration, where I describe what changed between versions. And I provide methods for translating between one version to the next. So if someone comes in and asks for a version from 2 weeks ago, I can look at the 10 methods between now and then, apply them, and change the resources appropriately. And I think my goal here was to do something similar, and something kind of similar to what I did with the snapshotting, which is if you can improve the observability into what's actually happening with your API and prepare for new versions to come out, you're going to end up saving yourself a lot of time in the future. So that's kind of how I approach this. So I made another library. It's called Pinned. These are all available on GitHub. I'll pass links afterwards. And this is very similar to how I kind of thought through the snapshotting, right? So we have a version, a change, and then we're taking advantage of Go's interfaces, right? We're deciding that every single resource in our API is something that can be versionable in the same way that anything can be assertable. So no matter what our API looks like, if it's a blog, if it's a social media app or whatever, we always know that it's a thing that's going to evolve over time. So we've kind of like future-proofed in that sense. And then we have methods to apply specific versions to that object. So just to give a look at what that actually looks like, this is gross. So this is going to get better over time, but everything's a work in progress. We add versions and we declare versions, right? And the idea here is a version gets released at a certain time and has a set of changes affiliated with it, right? So in this imaginary API, there's a user, and we've changed some fields about it, maybe we've added a date or whatever, we have 3 versions. So instead of having a lot of this logic in specific routes for getting users, maybe we have to copy and paste into the get all users or get user by ID or get my friends or whatever. I can isolate that all here and have it specific to an object that's versionable. And forever, as long as I'm running, this is the only place that my version logic has to be. So if we actually look at what a user looks like now, we haven't really done anything different, right? We've used a struct to declare what a user looks like. We've basically essentially kind of created the mapping for a user, which we probably would do anyways if we were serving a JSON API. And then we've added 2 methods that aren't necessarily user-specific, but augment a user, right? So they describe how a user changes. So instead of putting these things in switch statements or in different routes and making sure that it kind of all reconciles at the end, we've created very specific testable functions for understanding how components of a versionable object change, which are obviously easily testable then too. Now if we go back to our route for getting a user, imagine somewhere on the top we're actually looking up users in our database or something. But now all we have to do is determine the version that's being used, apply that version to a versionable object, in this case the users, and then we can send it back through the response. And I think what ends up being sort of most exciting here then is how the 2 projects work together. Right, so I've done all this legwork to understand how versions can change over time. Well, we can snapshot versions over time as well. So now we kind of merged the past and the now into the future. Right, the whole timeline is complete. We can iterate through our supported versions, use the HTTP test package again, record the responses, and then when we run our tests, if we're making a change that's a new feature, we can make sure that's not breaking older versions. And you can see that the sort of snapshots are able to document that as well. So to just sort of summarize, what we've done here, at least in versioning, is we've taken advantage of Go interfaces, so we don't have to really think about what our API is and what the resources are, but enable functionality to sort of span across all of them. And then again, we've integrated into our existing testing frameworks within Go to improve our observability. And then I think just to recap at the end, these aren't necessarily perfect solutions. These are ones that I've come up with that have worked for me. But I think the critical note is, there's so much that's already in the Go standard library that allows you to build these things so quickly. And if you can build tools that integrate with them directly rather than being highly opinionated, which is sort of a non-Go thing anyways, it's much easier for people to integrate them into their projects and actually gain value from them. And that's all I got. You're welcome to follow me here and check out some of my code online. I'm happy to answer questions now or later.